I want to begin our discussion with how to actually calculate and even understand the cut points for the ordered logit by first answering this question with the idea that we have some probability density curve that we're referencing, and we want to actually access the area underneath that curve in between the cut points. And so the key here is that for the ordered logit, we're going to be referencing the logistic function. Now, if we were doing an ordered probit, we'd be referencing the normal PDF. But to begin, I simply just want to talk about how we even estimate cut points for the logit regression. I mean, that is essentially what we're doing. We do have a cut point, and that cut point is at 0.5. So when we have an outcome, either male or female, and in this example, we're going to be estimating a logit regression. And for each outcome, we might have some set of covariates. The one that we're going to be using here is height. So if we have the height of an individual, can we predict their gender? And again, for observations that go over 0.5, so we have a 50% chance or probability of being male. If we have over a 50% chance, then we're going to assign that outcome to be male. And we can look at it in this context. So when we start off at lower heights, we have a higher probability or a higher percentage in our sample that are women. Now, as we increase in our height, the probability that a given person is man, or the percentage of males in the population, increases to the point where when we look at individuals who have height of 80 inches or higher, almost 95% of those individuals are males. So we can apply the same intuition, but instead of doing this for one cut point where we're dividing up a bin between 0 and 1, now we actually have multiple categories. So here we can look again at the logistic function, but instead of having one cut point at the probability of 0.5, we have different categories here with different cut points. So here would be the probability of falling in the first category. This would be the probability of falling in the second category, and so forth. So the way that we can interpret a change in the beta coefficient then is an increase along this logistic function. Now you'll notice that a beta shift in some portions of the function results in a larger actual substance shift in the probability that you're going to fall into a given category. But again, the way that we can interpret this beta is that a 1 unit increase leads to an increase of the probability of going to the next stage. So again, like I said, the impact of this is going to depend on your starting point. If you're starting down lower, a beta shift is going to equal a lower probability, right? We're going farther along this logistic function. Whereas if we're in the middle, a beta shift equates to a much larger shift in the probability of being in a given category.